Okay, so let us discuss an important property of Fourier transform, that is called as modulation property, which is very useful in the modulation of signals. This property is also known as frequency translation property. Modulation is also called frequency translation of the signal. Therefore, this property is also known as frequency translation property. So this frequency translation property, if you multiply a signal by sin omega t or cos omega t, then the frequency is shifted. Simple words I can say like that. Okay, so here xt is a low frequency signal, and then the modulated signal will be xt cos omega t or xt sin omega t. Omega naught is the frequency of the carrier, so it can be xt cos omega t or xt sin omega t. Okay, so according to the modulation theorem, if the Fourier transform of xt is x of j omega, then the Fourier transform of xt cos omega t is equal to half of x of j omega minus omega naught plus x of j omega plus omega naught. Xt sin omega naught t is equal to 1 upon 2j x of j omega minus omega naught minus x of j omega plus omega naught. Okay, so there are these two terms. I will prove one. The second part you have to prove similar to the first part. Okay, so I am taking only the first, xt into cos omega naught t. This part also can be done similar to the previous, xt cos omega naught t. Okay, let us take it. So xt, the Fourier transform of xt is xt into e to the power minus j omega t. Okay, this is the equation of Fourier transform, minus infinite to infinite xt to the power minus j omega t dt. And if I multiply xt with cos omega naught t, then instead of xt, here it will be converted to xt cos omega naught t, and the remaining e to the power minus j omega t will be as it is, e to the power minus j omega t dt. Now I can write cos omega t as e to the power j omega t plus e to the power minus j omega t divided by 2. Is this okay? And e to the power minus j omega t will be same as it is. Now we can multiply inside, so it will be omega minus omega naught, and it will be omega plus omega naught with minus sign. That can be written as half of j omega minus omega naught plus x of j omega plus omega naught. Similarly, we can prove for f of Fourier transform of xt sin omega t also. Yes, I think you should not feel a problem in proving that also. Let us take the last property of Fourier transform as per our discussion, is Parswal's energy theorem or Rayleigh's energy theorem. This is also known as energy theorem. Means calculating energy with the help of Fourier transform. That is a simple meaning of this theorem. Let us discuss the exact principle of the theorem. The Parswal's energy theorem says that the total average energy of any system or any signal can be obtained by its Fourier transform. So if I have x of t a signal and x of j omega as a Fourier transform of the signal, then I can say integration of minus infinite to infinite xt square dt is equal to 1 upon 2 pi minus infinite to infinite x of j omega square d omega. Let us take a simple proof of this expression. This is proof of this. energy is given by limit t tends to 0 minus infinite t tends to infinite minus t to t mod of x of t whole square dt. Or when I substitute the limit t equal to infinite, then it will be becoming minus infinite to infinite x of t whole square dt. Simple. It is simple. Now I can write xth xt into x star t, and x star t can be expanded like this, and xt is same. So 1 upon 2 pi will come out on xt x of star j omega into x of j omega d omega. This x of j omega square. So 1 upon 2 pi is extra, remaining is same. You have to remember only 1 upon 2 pi. Okay. Let us take some examples of this. Here it is asked that determine the energy if the Fourier transform is like this. This is one Fourier transform, this is another one Fourier transform. The procedure is very simple. You have to take just a square of the values given. Here you can see 1 upon 2 pi minus infinite to infinite x of j omega mod square dt. So we don't have to worry about the minus. So 1 upon 2 pi x of minus pi square plus minus pi square or plus pi by 4. Let us see here. So it is here that root over pi by 2. So pi by 4 will come, or pi by 2, it will come pi by 4 or minus pi. Root over pi will square become pi. Y minus, which coming? Minus will not come here. Should be positive. It will be pi and it will be pi by 4. Okay. So pi and pi by 4, 1 upon 2 pi. So this will become 4 pi plus 5, 5 pi by 8, 5 pi by 4. So this will become 2 pi by pi will be cancelled, and because pi to pi and pi is cancelled, so it will become 5 by 8 watt. So total energy will be 5 by 8 watt. In second expression, this is minus j root pi and j root pi. Let us see. So minus j root pi and j root pi. Okay. Whole square becomes j square pi plus j square pi. It will become 2j square pi and divided by 2 pi. So pi and pi cancel, and result will come at j square pi minus 1 watt, and because in power we take the mod, therefore it will be 1 watt. Okay, because we take mod of this, mod of x of j omega, therefore answer will be 1 watt. Okay, this is for you, practice problem for you. You can note it down and solve this as a tutorial problem. This is a tutorial problem. Okay, so this is, I'm ending this video here, and this problem is given to you for solving. Solution is started although, but it is okay. Just take the problem till now, till this place. Find the energy of the signal xt equal to 10 e to the power minus 80 ut contained in the frequencies minus a upon 2 pi to a upon 2 pi. What is the percentage of total energy? What percentage of total energy is this? Okay. Thank you. Thank you so much for watching this video. If you are gaining knowledge from these videos, you can like and subscribe.